Okay. Newton's second law, we are going to be going through free body diagrams that you are going to be asked to solve. So if you guys cannot do this, this is going to be very problematic. Okay, so we need to be at least adept, whatever, I don't know the right word, at being able to solve for a net force if you're shown of everything on a free body diagram. All right, so look, opposite directions, what do? We subtract. Same directions, we add. So first one, we get 100 up, 100 down. So for me, those two things, they're equal. So I don't really even care about that. Friction force is 20 to the left, and then we have applied force, which is 20 to the right. You guys don't need to draw right here what I'm showing you because I'm just showing you that they're balanced, 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 balanced. So what you really are going to have here, what is the net force for this dude? F sub net is going to equal what? Oop. Anyone? Good, 0. Everybody bounces. Okay, well, what's going on here? We got tension is 400 up, and we have weight, FG, 150 down. So what do we have here as my net force, or our net force? F sub net equals what? Rose. Shadow. 250, good. Now all you had to do is subtract the 2. So this one, we have 600 up, 600 down. They balanced. So we have 250 to the right as our applied force with a friction force of 175. I'm sorry, of 75. 250 to the right, 75 to the left. Net force is going to be 175 in which direction? To the right. What the French toast? Oh, I took that off. That's why. So I'm just putting the F net like in the direction on. Well, if it's to above, I'm just dragging it here for the right side. Okay, you guys should be able to handle the others for sure. Now, hopefully this worked because I tried making the edits yesterday. Do you see these equations on your doc? All right, bet. So we know from the last couple days that net force is equal to the object's mass times its acceleration. Net force and acceleration have to go in the same direction. Now, if you're asked to find normal force, all right, unless told otherwise, everything's going to be on a surface, right? The only one, like in the first 3 that we did, is not on a surface is tension, because that tension is like usually meant we're using something getting pulled by a string, rope, something like that. Normal force means we're on a surface, and we're assuming that they are all horizontal surfaces, which means the weight and normal force are going to be equal to each other. So to find weight, it's mass times gravity. So they used, that's kind of annoying, but what I would like us to use is gravity here is 10. Now, obviously, 5 times 10 should be 50. This doc here, all right, it started off using it, I guess, as 9.8. So that's maybe why it's a tiny bit off on a couple of them. But for the ones like this, all right, we have mass here of 12 kilograms. What would F sub G be then? So F sub G, weight is mass times gravity. Mass is 12. We're using 10 for gravity. So all right, 12 times 10 is going to be what? 120 newtons. Now, normal force and weight are going to be the same, so this dude here is just 120 newtons. Now, if you look at this, you got 120 up, 120 down, balanced. We have a friction force of 20 to the right, and an applied force of, applied force of 20 to the right, friction of 20 left. Acceleration, if I covered it up in the triangle, is F net divided by mass. Well, what is my F net here? Zero. This guy balances and this guy balances. So you're left with a net force of zero. Zero divided by anything is going to be zero. So that is where we are going to have zero for our acceleration. Okay, well, let's take a look at one that doesn't balance. Let's take a look at one that does not balance. So if we're looking at number 2, top and bottom balance out, cool. Left and right, do they balance? No. We have 70 to the right, 20 to the left. So what would my net force be for this guy?
50 to the right.
Good. So we got 50 newtons. All right, to the right. So I'm just going to put F net, bam, right over here. 50 newtons. It's going to the right side. Now we have a mass of 5 kgs. So to find acceleration, if you cover that up in the triangle, pretend like it's not there, all right, it's F net over m. So net force divided by mass. I'm just going to show the work over here for a second. All right, so that'd be 50 newtons divided by 5, which is going to give us an acceleration of 10. Oh boy. Oh jeez. What does anyone know what to do here? I'm confused. We have to find mass and the 2 missing pieces of information. So how the heck do I do that? So I need mass, right? In order to solve for mass, because I'm not given the weight of the object, right? Like if I was given the weight, I could basically divide by 10 or the 9.8 and get mass. But I'm not given that here. So what the heck do I do? I'm given acceleration. I'm not given mass. That's what I'm looking for. So what else would I need? I would need the net force. Okay, well, in this diagram, these 2 little lines here telling us that these 2 are balanced. So could I find the net force just by looking at the diagram? I think so. I hope so. Anyone know what that would be? So guys, at the top and bottom here balanced out. We're pretending like it's not even there for the second. 240 to the right, 80 to the left. What is my net force?
160 to the right.
Good. We have F net, and that is going to equal 160 newtons to the right. How can I get gravity? How can I get my weight? F sub g is mass times gravity. So I need to know what the mass is. Crap, don't know what that is. Huh. Well, now that I have net force, I have F net and acceleration. So to solve for m using the triangle, all right, I'm just going to copy this actually because that's annoying to write every single time. F net, or let's see, wrong spot. M is equal to F net divided by A. So F net was 160, and the acceleration was 4. What's 160 divided by 4? 40. And the unit for mass is kilograms. Now can I solve for weight and normal force? All right, well, what's weight? F sub g. F sub g is mass times gravity. Now that we have mass of 40, what do? M times g. G we're using as 10 meters per second squared. So what's 40 times that guy, right? mg, which equals 40 times 10, which is going to give me a weight of 400 newtons. You scooter. So if my weight is 400 newtons and these two forces are balanced, that means the normal force has to be 400 newtons, yeah?
Yeah.
All right.
Because you did 40 times 10.
Yeah, right? So Fg is weight, mass times gravity. We figured that the mass was 40, 40 times gravity, gravity's 10, 40 times 10 is 400. And since those two are equal, if you're just looking at the diagram, normal force is going to be 400. Okay, so now let's run through these. Next one, what do? All I'm given is a normal force of something, but I'm not seeing anything equal here. Well, not a bad guess. Not a bad guess. Dividing 160 divided by 8 to get acceleration. Well, that's normal force, not net force. So you see, right, like in these pieces here, that those two are equal to each other. Here, hopefully you can see it. This vector, the normal force is greater than the gravitational force. So that could be something like the ground is pushing up, all right, against an object's weight and still be making it, accelerate in the positive direction. So, well, if you're given mass, can you always find the weight? Yeah, mass times gravity. So, yep, 8 times 10, that gives us 80 newtons of weight. So now what is my net force here? Opposite directions, what do we do with them? Subtract. So we have, what is it? F net is going to equal 80 going up. Sounds about right. And acceleration in the equation is F net divided by M. So 80 divided by 8, which is going to give us 10 as our final answer here for our acceleration. 10 meters per second squared in the positive direction. I guess so. All right, they're saying acceleration right. They're saying acceleration right. This one would be also to the right. This one would be up. Okay, next one. What can I do? All right, so one thing I can definitely do is mass times gravity, mg, which is 40 times 10, which is going to be 400 newtons as my weight. And since I'm looking at the diagram here, my free body diagram, and I can see that these two vectors are equal, that means the normal force will also be 400. How can I find the friction force? We don't have an equation for that, right? Not a bad. That's not a bad guess. That's not a bad guess. 200 divided by 4. Well, what when you have mass and acceleration, what can you find? we can find the F net. And then it's like kind of reverse engineering. If you know what the net force has to be, you can then figure out what the missing piece should be in order to make it true. So let's find F net. So we're going to do mass times acceleration, which is 40 times 4, and that is what, 160? Does that sound right? Okay, now since the acceleration is to the right, the net force has to be to the right as well. So guys, if I just showed you just this drawing without any numbers, any other numbers, right? Without mass, without acceleration, if you just knew that the net force of this diagram had to be 160 to the right, what would friction be? How would you figure that out?
Say that one more time.
So you're looking at the picture. If I said to you guys, hey, this is like one of the first problems we did when we were doing mechanical equilibrium. How can I get the net force to equal that 160 to the right? Top and bottom are already balanced. So good. Subtract 200 and 160, which would give us 40, I think. Sounds about right. Okay. Now, if you're not sure, just double check. All right. Once you write that value there, double check. Opposite directions. What do we do with our vectors? Subtract them. So if we have 200 to the right, 40 left, 200 minus 40 would give me 160, and it would be going to the right because the 200 Newton dude is greater. All right, bet. This one's make it easy. Just another reverse engineer. You're given normal force. You can see that these two are equal. Yeah? So normal force is 500. What should the weight be? 500, because they're equal. So I don't even have to do anything. But if I know my weight, I can solve for mass. Weight divided by gravity will give me mass. So we can do weight. No, it doesn't work here. Weight of gravity, right? Your weight divided by gravity. So we're going to do 500 divided by 10, which gives us a mass of 50 kilograms. Now what? Is there any other force going on here except for friction? Do you see any other vectors to the left or to the right? I don't. So the up and down, balanced. So if there's only one other force, guess what? That's your net force. And so they want acceleration. Acceleration is F net divided by m. So in this case, the F net is going to be friction, and the reason is just because there's no other vector, right? So when we had this guy over here, this wasn't here originally, that 40 newtons. So we just had 200 to the right, but we still had this vector over here. So that wasn't just going to mean straight up that the 200 was our net force. All right, so here we have this guy isolated. He's by himself. There's nothing going in the same direction or opposite. So this happens to be our net force because these two are already balanced. So the acceleration is F net over m. So I'm just going to do it underneath. Excuse me. And what the hell is that? F net was what again? 125. And the mass was 50. And that equals what?
2.5.
2.5. All right, so we're going to have our acceleration of 2.5 meters per second. What direction was our net force?
Left.
To the left. So our acceleration has to go to the left. Acceleration has to be the same direction as your net force. Okay. So you guys make sure that you finish, all right, these second three here, and then that will be good for you guys and you can submit. So take one last gander here. I will post this video later. So if you missed something or it was going a little too quick for one problem, go back and watch it. You don't have to watch the entire thing. You can go to the part where you maybe missed or were not 100% sure on. All right, that's why I make these. Okay.